Welcome to the first video in the series I'm calling Flipped Sign, where basically we go into certain physics equations and we ask, hey, why is there this minus sign? And as you can see today, we are going to focus in on this guy right here. F of x is defined to be the negative derivative of u with respect to x, where u is the potential energy. So let me go ahead and insert my little picture here. So just as a quick reminder from Physics 1, you may recognize that x is equal to 0 is an equilibrium point, and furthermore, it's a stable equilibrium point, right? And that's because the derivative is equal to 0, and it happens to be a minimum. Or in physical terms, you can look at this as this position right here has a lower potential than either of these 2 points. Okay? So now, since the force is defined in terms of the derivative, let's look at the derivatives. So here we have a negative slope, and as we all know, the derivative corresponds to a slope at a point. So here it is negative, and of course here it's positive, right? So that's where these guys are coming from. We're just looking at the slopes, okay? At the associated points. So now, of course, the question comes in, so why is there a minus sign? So let's imagine for a second, and this is where we're really going to look at this guy. It's really useful to think of force as a vector because, well, it is. It gives you a magnitude and a direction. So let's go ahead and treat it like that. So we're just in one dimension. So we don't need to worry about x and y, but you could also do this for that. And I just copied the definition, the correct one, but we're going to assume for a second that this is actually the definition right here, okay? So what does that mean? Well, so we just saw that in this region over here, right, the derivative is positive. So basically, coming over here, we would have a vector pointing to the right. Why? Because du dx itself would be positive. So we're going to get a force which points to the right. Okay? And by similar argument, in the left over here, in this region, this guy over here is negative, right? So we're going to get a force which points to the left. So what's wrong with that? Well, if we imagine that we have a little ball here, let's imagine he's at that equilibrium point, and we give it a kick to the right. So what's going to happen? Well, what's going to happen is that even though there's no net force here, right, initially we give it that kick, well, now there's a force going to the right. So this guy's going to keep on climbing that wall, right? Similarly, if we started here and give it a kick to the left, well, it would just keep going and going and going, right? And you could think of a bowl. If you were to put a marble on the rim of a bowl and give it a little kick in the bowl. So, maybe we have a marble right here. We give it a kick in the bowl. Well, you would expect that it falls down, right? But according to this, we give it a kick and it's actually going to go up. And that doesn't make any sense, right? So we can't have forces which point away from that equilibrium point here, right? So what we actually need to do is we need to put a minus sign. Now, what does that minus sign do? That minus sign flips the direction of these vectors. So now over here in this region, instead of pointing to the right, we're pointing to the left. And over here in this region, instead of pointing to the left, we're pointing right. So now this should start to look familiar. So now if we give this little particle in the center of the, you could imagine this is some kind of bowl. If we give it a kick to the right, well, yeah, it'll go up for a little bit. You know, maybe it reaches here, but then because of F, it's gonna come right back down. And you know, if there's no energy loss, then it'll reach the same potential height. And it'll just keep doing that, you know, then it'll go back this way. So on and so forth forever, right? And of course, in the real world, there is energy loss. So eventually, you know, the maximum will be right here on that initial kick. Then the maximum will be right there. Then it'll be right there. Then it'll be right there. Then right there. And then eventually it'll settle down at the bottom, right? So essentially, that's basically all there is to the story. That's why we need that minus sign on the derivative. So it's not just some kind of arbitrary choice. This is actually reflective of reality, right? So I hope you found that helpful, and we'll be doing more videos on this. Just leave a comment below if you have any suggestions on what you'd like to see more of in the flip sign series, and I'll catch you in the next one. Have a good one.